Hey guys, welcome back to another RESK Maths tutorial, and in this tutorial I'm going to be explaining to you guys how equations with lines actually work. So let's look at a typical example of an equation of a line, and it's usually in the form y equals mx plus c. So let me get into this stuff. X and y, well, these are both variables, so variables, these can take any value, and we can actually just say y is a function of x. So y is going to be determined solely by x. And obviously these variables are important because they make up the axis. So the x-axis is called that because it is the value of x. And similarly, the y-axis is called that because it's the value of y. So you've got the variables. Now m, that's actually the gradient. So let me draw that, and that basically means how steep the curve or the straight line is. So if it's minus infinity, okay, let's not talk about minus numbers yet, but if it's a really low gradient, like 0.0001, it's going to be something like that. So like a very unsteep line. And if the gradient is very high, like 100 or 150 or like infinity, nearly. Infinity is a straight line, but nearly infinity, that's going to be really steep like that. So you can see these are different types of gradients, and a negative gradient, they work in the same way. So a negative small gradient, that's going to be just slightly downwards, and really large magnitude negative gradient, that's going to be a really steep downhill line. So anyways, that's the gradient, and finally we have the y-intercept. And this is really simple. Basically, on this line, the y-axis, x is equal to 0 at all points. So what we can do is we can actually just, if we put 0 into that, then this whole thing's going to disappear, which means we're just left with c as the y-intercept. So that's why if c was equal to 5, then the line will pass through the point 0, 5. And it might look like that, it might look like that, depending on the gradient. But yeah, c is just the y-intercept, or the point at which it crosses the y-axis. So yeah, thanks. Sorry, let me show you an example. Let's have y equals 5x plus 6. Okay, so this is going to look like this. Now it's easy to sketch this graph because we know all the information we need. So we know it crosses the y-axis at 0, 6, given by the y-intercept. We know it has a gradient of 5, so it's going to be relatively steep, like this, and then cross somewhere over here. And obviously, we can actually work out what this point is. This is actually called the x-intercept, and you work it out because along this line, y is equal to 0. So when we put y is equal to 0 into there, we get 0 equals 5x plus 6. And with some algebra, you'll find x equals minus 6 over 5, or minus 1.2. So this point is actually minus 1.20, just like that. And there's our line. We've managed to sketch it nice and easy. We've got the points of intersection with the x and y axis, and we've also got the approximate gradient. So let me show you one more example, and that will be it. Actually, let's do it in a different form. So this time, let's have 5x plus 7y equals 10. And this is a certain form you might have. It might also be 5x plus 7y minus 10 equals 0. This is another form. Yeah, sometimes we like to use this form when we have two variables and we want to show that they sort of add up. So an example of this might be a supply and demand curve, which is only in the positive directions. So let's have x, y, and let's just say x represents the supply, or let's say x represents the price and y represents the demand. So obviously it's going to look something like this. As price increases, demand decreases. And we might use this form because in this case it's easy to show what each variable is when the other one is 0. So if it was 5x plus 10y equals 20, well, when price is 0, demand is just going to be 2. It's easy because this term disappears. Similarly, when y is 0, so when demand is 0, the price would have to be 4 because this term disappears, and it's just easier. But if we want to sketch it, we can actually keep it in this form, because then this gives us our 2 points easily. We can just work out when x equals 0, we can work out 10y equals 20, so y equals 2. So we could easily just write there's 2 there. When y equals 0, we get 5x equals 20, or x equals 4. So we get that is 4. And then we just have to join these points. Remember that for a straight line, you only need 2 points, and then you can draw a straight line between them, but you should probably get 3 just to confirm. And let me just show you guys what this equation would look like in the form we discussed earlier. So first of all, we'd move the x to the other side, and then we'd divide everything by 10, just like this. And you can see this is actually going to make the same curve. It has a y-intercept at 2, comes down at a relatively unsteep gradient. We know this is 4 from working it out. But yeah, thanks for watching. That was the equation of a line, and it basically describes how y changes when x increases and decreases. So thanks for watching, and I'll see you guys in a future tutorial. Bye!